In the last lesson, we created our first YOLO node in ROS 2. So we moved from a standard Python YOLO script to our very first version of a ROS 2 YOLO node. But although it was impressive as a demo for your non-technical friends, it's not quite useful because it's just showing the detections on the frame, and it's not even using ROS to show the detections. It's using standard OpenCV, a standard OpenCV window. Now, before we can do anything useful, we need to perhaps learn how to publish that frame so that, let's say, another node processes it. But that's also not very useful, let's say, but we're still gonna do it just so that you learn how to publish in case you have never published, in case you have never created a publisher, but also because sometimes we want to just, for debugging purposes, we want to see this data in RViz. We normally don't want to open an OpenCV window. So we're going to instead publish this annotated frame as a ROS2 topic, and we can look at it or subscribe to it from RViz, which is the most widely used visualization tool for ROS. So what we're going to do today is just that. We're going to extend the YOLO detector node 1 that we saw last time. We're going to create a second version that pretty much all it does is to publish the annotated frame. So it's going to be a minor change, so fairly short lesson. So before we go into the code, let's have a look at it. Okay, so remember to go to the correct folder and use this so that we can have access to the screen, and then start the Docker container. And then here, don't forget to source. I assume that you already built, so don't forget to source the workspace. And then ROS2 run RSC, and then here YOLO node 2. And it's gonna be ready for us, and subscribing to this topic just like before. And it's waiting for the ROS back to start playing the data. Okay, so here we are going to go into or attach to the container, and we are going to source the ROS workspace so that we can play the bag, and we're gonna go one level up in the folder in the workspace, because that's where the ROS bag is, this one. Okay, so we're ready. We don't have to play yet because I want to open RViz. So attach again to the container and source the ROS workspace. And so let's run RViz. And here, I'm just going to open a configuration that should be in our workspace. Oh, sorry. I think I need to do something before that. Otherwise, it's going to fail. So I need to also sort this source the ROS2 workspace, not just the ROS humble workspace, but also our current workspace where the code is. If I don't do that, so something's not gonna load correctly. And then I'm gonna open a configuration as I was doing earlier, and I'm gonna find the URD, no, not the URDF, my bad, the RViz, this, and here just quickly, because this path is actually not correct, I'm going to load the correct URDF. And this is not really necessary because all we care about is actually the image here, but it just looks nicer if the robot shows when we play the bag. So now we're ready to play the bag. And here we're going to do ROS to bag play, linko dash, and it starts playing. And by default, this, here's the robot, by the way. So by default, this will play the original image, right? The original image that's coming from, or the original stream that's coming from the bag. So now this guy is actually running and is actually publishing the annotated frames into a new topic. So if I go here to the image visual, or the image visualization tool, and I click here, there is a new topic here called detections image annotated, which has been published by our YOLO node. And as you can see here, it is indeed the annotated frame. It's a bit slow again, it's because my virtual machine is not the best one, but it should probably run better on your machine. So it's working. So we're publishing the annotated frame. As you can notice, there's no OpenCV window anymore. That's not the way you do it. If you want to see the annotated frames for debugging purposes, you publish it as an image topic, and then you view it from RViz or any other ROS tool. Okay, so we're gonna stop this. It's clearly working, and we're gonna stop it, and we're gonna go to the code. So here's the code, and everything will look familiar. We have the YOLO detector node. We initialize it. I'm only gonna talk about the differences. So one of the differences here is now we have a topic out variable that contains the name of the topic where we're going to be publishing, and as you saw in RViz, the topic name is detections image annotated. So this is the name of the topic. Everything else is familiar. Here is another change. Now we have a publisher. So we have a variable or a member of the class called image_pub. This is just a name. You can call it whatever you want. But this is the important part. You create a publisher. And again, you can do that with self.createPublisher because you are a node, you're a ROS node, right? You are inheriting from node, from rcalpy.node. You're importing the node class and you are inheriting from it. So this gives you the ability to create publishers, just like you also created subscribers before. So you create a publisher. The data type is image, just like the subscriber, because we're subscribing and publishing images. And this topic will use the topic out variable. And this is for the quality of service profile depth. So don't worry about that for now. That's for another class. And then there you go. So we just say that we are subscribing to something and publishing to something, as you could see from the output when we run this node. And then the only other difference is in the image callback. Whenever you receive an image, we convert it right to a CV image with the bridge. Convert it to a OpenCV image. We run the inference. We obtain the results, and then we plot the results to generate the annotated frame. This is the same as last time, but the difference is that instead of opening an OpenCV window, we are going to try to publish the image. And before you can publish, we need to convert that image back into a ROS image, right? So the opposite of this. Here we went from image message, because that came from the topic, to CV2 to do the YOLO detection. And now the annotated frame is a CV2 or OpenCV image. And now we need to go from OpenCV to image message. So from OpenCV image to ROS image. So the opposite process. And this is now the annotated message. We need to give it a header. And So this is the same header that we got from the image that we received from the bag. So it's assuming that the same sensor or the same camera is publishing the annotated message, or is in the frame of the camera that received the original image. And here's where we actually do the publishing. Okay, so we actually do the publishing. And that's it. It's pretty much the difference. That's the main difference between the two. If you wanna see it side by side, you can always go to select for compare, and then compare with selected, and you can see that the differences are, well, mostly names of things. But here there's a new topic. There's a publisher that wasn't there in the other code. So yeah, so you can actually see here he was showing the image with the OpenCV, but here we're publishing. And here we destroy the OpenCV image, but now we don't have to do that because we don't sorry, not the image, the window. And now we don't have to destroy any window because we didn't have that. So that's pretty much it. And it's working. So now we are visualizing for debugging purposes the annotated frame in the correct way with ROS topics instead of opening a window, an OpenCV window. All right, in the next lesson, we're going to do something more interesting, which is actually publishing the raw detections. And that will take you from really like a simple demo to something that is more realistic, more like what a computer vision pipeline should do. And so see you in the next lesson.